Good afternoon and welcome to a video lesson about reciprocal trigonometric functions. Not sure if you're going to watch this, but let's do something quick just to run through a few things. So we have these things called reciprocal trig functions or trig ratios, and they come from sine, cos and tan. So cosec, CSC or cosec, which is actually short for cosecant, is 1 on sine x. Secant of x, sec x, is equal to 1 on cos x, and cotangent is equal to 1 on tan x. And so we can use some techniques, later we'll look at the graph, to how we're going to do that. Now, if we have a look, you'll remember that there is this thing called the trigonometric identity, which is sine squared x plus cos squared x equals 1. And actually what we see is that there is a relationship for both, well, that links cosec and cot and sec and tan if we use this relationship here. So I'm going to put a red box around this so we kind of remember. Sometimes you see cosec actually written as that with cosec, C-O-S-E-C, and in the IB course they just use CSC to keep it to 3 letters. Now I'm going to do 2 versions here. So if I just split the page in 2, the first one, so we have sine squared x plus cos squared x is equal to 1. That's always true. Now if I divide everything by cos squared, so divide by cos squared x, divide by cos squared x, what do we get? Well, sine squared divided by cos squared becomes, well, I'll just write that as that, sine squared x over cos squared x plus, well, cos squared x divided by cos squared x is 1 equals 1 over cos squared x. Now you can see that the first one is tan squared x plus 1 is equal to 1 on cos is sec, so it's sec squared x. So here we have a relationship between tan squared x and sec squared x, which comes from our identity. Now, it's kind of helpful to know you don't need to necessarily remember it. You can always derive it by thinking, take the sine squared x plus cos squared x equals 1, divide by cos squared x. Now what happens though if I divide everything by sine squared x? So if I take sine squared x plus cos squared x is equal to 1, I divide both sides by sine squared x, divide by sine squared x. First term becomes 1 plus cos squared x over sine squared x equals 1 over sine squared x. Now, the thing is, sine over cos is tangent, which means that cos over sine is the reciprocal, and the reciprocal of tan is cot. So this actually becomes cot squared x. So there's 2 ways I can actually think about cot. And 1 over sine is cosec. So this becomes cosec squared x. And so here we have another identity that links together cot and cosec. Again, it's derived by dividing through by sine squared x. Just 2 kind of cases which we can use. Now, let's move on to talking about the graph. Now, I'm going to do 1 using a particular technique for 1 over f of x, and then you see if you can go through and do it for cot and cosec. I'm going to do it for y equals sec x, which of course is 1 over cos x. Now, given the similarities between cos and sine, you would assume that there would be some similarities between sec and cosec, but I'll let you kind of think about that. So first step that we need to think is, when the function cos of x is 0, 1 over cos of x is 1 over 0, so that means it's undefined. So here, these values is undefined. So it must have a vertical asymptote. So I'm going to draw those in. Draw them in, and you can tell that this would actually keep going indefinitely. The pattern would be repeated because it is still a periodic function, just not a wave like cosine is. So here we have asymptotes going all the way along. Okay, now let's think about certain key values. Now the most obvious one is here. It's at 1. Now if the value of cos x is 1, then 1 over 1 is 1 as well. If the value is -1, then it's going to be 1 over -1, which is -1, etc. So there's going to be these points that they're touching all along here. So all these black points are where the curves intersect. Now the question is, which way does it go? Think about this middle section here that I'm kind of pointing to. As the curve decreases, so let's say we get to a half. If cos x is a half, it's when it's pi on 3, or 60 degrees, 1 over a half is 2. So actually that's up here. Same across here. When it's a half, it's actually 2. So as cos x decreases, sec x increases. And as cos x gets really, really close to 0, like 0.0001, 1 over 0.0001 is like 10,000. So it's actually increasing, approaching the asymptote, but never actually touching it. So what happens is we get something like this. And it flattens out at the top, and we have something going like that. Now what about here? Well, similar idea. It's negative a half, so it's going to be -2. Negative a half, it's going to be -2. So it's approaching the asymptote in the negative direction. Going like that. And that is just repeated given its periodicity. It's got to be periodic all the way along, and there we have it. Now you can imagine that cosec might look very similar. That's y equals sec. Cosec might look very similar, but I'll let you do that. You can check it out on Desmos and see what happens. But cot might be a bit more interesting when you look at tan. And I'd encourage you to think about it not as 1 over tan, because the asymptotes can get confusing, but think about it as cot x is equal to cos x over sin x. So that may give you an idea, and it might end up looking quite similar to something we've seen before, but see how you go with this. Okay, now one last thing is, now that we have some other reciprocal or other trigonometric ratios, we can do a whole lot more simplifying. So we've got something like this. 2 sin x cot x plus 3 cos x over cot x. We want to simplify that. Now, remembering that what I just wrote before, cot x is equal to cos x over sin x, I'm going to write this as 2 sin x times cos x over sin x plus 3 cos x, that doesn't change, over cos x over sin x. Okay, let's see what happens next. Well, do you see that the first term, we've got sin x here and sin x, so they go away. So we're going to have 2 cos x plus 3 cos x over cos x over sin x. Now the numerator becomes 5 cos x. Could have done that in one step, but that's okay. Cos x over sin x. Now, the cos x's, well, outside on top, inside on the bottom. So this actually becomes 5 cos x sin x over cos x. And if we just simplify, it ends up just being 5 sin x. So with trig ratios, a whole lot of complicated looking things, because of the interrelatedness of them, they end up being quite similar. So go and have a go at the exercise in the chapter 12, which looks at this stuff, and I'll have another short thing about reciprocal trig functions. Sorry, inverse trig functions, my mistake. Okay, happy graphing and problem solving.